Hello, hello, hello. It's good to see you guys again. Sort of. Sorry I'm out today. I apologize for that. Sadly, there's still some ice on the roads near my house, and so I'm not able to get into work today. So let's go ahead and get started, though, on the exponential graphs, how to graph them, and how to calculate them when it comes to some real world scenarios. And to get started on that, all right, we have to take a look at some of the things that y'all were just tested on. We need to make sure that you guys understand what A and B stand for when it comes to these exponential graphs, okay? So once again, A. A is our starting value. It's our initial value. It's like if you get a bank account, how much you first deposit. If you're buying a car, it's how much the car is worth when you first buy it. If you're going to be talking about the growth of cells, it's how many cells there are when you first get started. If you're talking about a decrease because of the radioactive decay, because it decays at an exponential rate. Then you're talking about how much your initial sample size is. If we're talking about population growth, you're talking about the initial population. It's where we're starting, okay? From there, B is the growth factor. All right. Now, that growth factor word is kind of a little bit misleading in the way that it's said, okay? We talk about growth and we think about growth as if something is getting larger. But see, the thing is, we can also get smaller on this growth factor. Yeah, I know math is a little bit confusing like that, okay? That's the rate that something grows. For those of you that already have bank accounts, if you have a interest rate, there's something that the banks will give you money to have your money in their bank. Usually it's like a 2% per year kind of thing. It's just a little something that they deposit a little money into your account based on how much money you have with them. That percent that they give you back is the growth factor. If you're talking about, again, cell growth, we're talking about how quickly those cells multiply and how many cells there are each time. If we're talking about a car and how much value it loses over time, because, cars lose value because they age, right? What percent do they lose per year? If we're talking about population growth, at what percent growth does it have per year? Or sometimes there's population decline, right? And that's at what percent it declines per year. All right. Notice I'm saying percent. Whenever we talk about this exponential growth or exponential decay, you're almost always going to be talking about percents. Okay. The only time you're not talking percent is when we're talking about it grows to be twice as many every 6 months. Okay. And in that case, then we're talking about it being like a 200%. Okay. And even then, that twice as many can convert to a percent. All right. The key note about B is we're always comparing it to 1. If B is larger than 1, then it is an exponential growth function. This is something where your values are going to get large over time. And if B is smaller than 1, you're going to see it shrink over time. And I've got a couple of examples a little bit further down on this page where you're going to see this 1.5 here. Ooh, that's not a good color for that. Let me go back real quick. Again, that B that's right here, 1.5. Since that is larger than 1, we see where that graph starts low and then it starts climbing upwards and upwards and upwards and upwards. And it goes upwards faster and faster and faster, okay? This is an exponential growth function. Then from there, we've got an exponential decay function next to it, where once again, B is right there inside the parentheses. You're going to see where it starts high and comes down, 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 and flattens off over time, okay? It's going to talk about how things decay. Now, right now, we're talking about numbers that are kind of small, right? We're starting with an initial value of 1 on these graphs, but it doesn't always start at 1. If we're talking about like a credit card balance, okay? If you're trying to pay it off at 5% per month, right? Then you're going to be starting at something like $5,000 and you're paying it off at such and such percent per month. And so you're starting at a value much larger than 1. So this graph is a little bit misleading in how quickly it gets down to that asymptote there at 0, okay? Now, I need you guys to pay attention to that increase or decrease, because when we start talking about these real world situations, you're going to have to be able to tell me if the value that you're starting with is increasing or decreasing based on the question that you've been given. All right. I've got a 6-step program for you to be able to get the actual graph and table. Don't forget, you're going to have to generate that table on your calculators in order to be able to get some of these answers. Okay. So step 1, we are going to write your starting value from the question and open some parentheses. So let's go ahead and do this first example real quick by following these 6 steps, and you'll see what I mean. When it says write your starting value, I'm going to put that in green. Starting value. Ugh, that's not a highlighter. Let's put it in the highlighter. Starting value. Each month, the bank puts interest into your account based on the amount of money in it. Yes. The amount they give is 1.5% of the amounts in your account. Great. Percent. You're not starting with a percent, so that's not the number I'm looking for. If you put $1,000 in your account and leave it alone, now there's a reason I highlighted that green, is because you are starting with $1,000 in your account. And then we're going to go ahead and open some parentheses, okay? From there, read the question and decide if the percent being applied makes your value grow or shrink. And again, I say that percent because it's almost always a percent, okay? Percent grow or shrink. It goes, they give 1.5% of the amount in your account. When I look at that, I know that that is going to be growing. They give you that money. They're not charging you for it. They're giving it to you, okay? Now, convert that percent to a decimal. How do you take 1.5% and convert that into a decimal? You take that and you move that decimal place 2 places to the left. In this case, you'll notice that that becomes 0.015, okay? From there, is it growing or shrinking? If it's growing, like right now, it is in fact growing, okay? Then we are going to add that decimal to 1. We're going to go, what is 1 plus 0.015? In that case, I get 1.015. Okay? Now, if this was decay, which you will see in just a little bit, you're going to see it decay. That is going to be where we would do 1 minus that percentage. And we will do an example with that decay. We go ahead and close those parentheses and cap it with an exponent x. That gets graphed, okay? So I take that 1,000 parentheses 1.015 raised to the x, and I go to my calculator and I type it in. 1,000, open the parentheses, 1.015. I don't need the percent symbol. I go ahead and close those parentheses, and I raise it to the x. Now you'll notice I got some values that show in my graph on the left side, right? But I can't see anything on my graph. And that's because my y-axis right here, my numbers are kind of small. If I zoom way out, ooh, now I can see that graph. I can see where I'm going at 1,000, and I see where it's going up and up and up and up and up. It does take a little bit more to climb up to 1,000. Like, look, we're going way back over here, but who cares about the negative numbers? We care about where things are positive, okay? That graph is important. The table over here on box number 3 is a little bit more important, okay? So don't forget, in your calculator, you're going to graph it by pressing home and then pressing B for graph. Menu 3.1 is going to give you the ability to type this equation in. Get that equation typed in. F of x equals, and just like I have it here, 1,000, open parentheses, 1.015, close parentheses. You're going to want that little caret button. That's going to be that little arrow up that's right next to the button that says x squared on it. Then you're going to push the letter X in white at the very bottom of your calculator. That is going to give you this graph. If you want to see a table, it is going to be menu 7 and then show the table. Okay, I think it's menu 7.1. When you press that, it is going to give you the table, and you can use the up and down arrows right underneath the screen to be able to get that table seen, and you can scroll up and down and see what numbers you have there. Now, once again, when I look at this, we want to be very careful and read this question just now, okay? If we look really closely, they give you the 1.5% in the amount in your account. How much would you have in your account at the end of 6 months, 1 year, 2 years, and 5 years? In this case, that 1.5%, we're going to count it as if it is a monthly rate. The question will usually tell you what kind of rate it is, okay? So if we're looking for it at 6 months, when I go back to my function table, I'm going to be looking here at 6. Ooh, I don't want to do that. Undo that. I want to put it here, and I want to turn that into 6. That first number that I see here, the 1,093.44, at the end of those 6 months, that's what the amount of money in that account is going to be. So I go back over here, and I tell you that it is going to be 1,096 or what is it, 1093.44. Let's do it in text, because that way you guys can actually read it. 1093.44. That's how much is going to be there after 6 months. Notice it says a year. Instead of 6 months, a year is going to be 12 months. And that's 1195.62. Why 62? Because 0.618 rounds to 0.62. So 1195.62. So go ahead and put that in here as well. Come on, give me my text. 1195.62. Okay. Push you back. How about 2 years? How many months is in 2 years? Well, that would be 24 months. Okay, now we're getting somewhere. 1429.50, $1,429.50. So I go back over here and I click 1429.50, I believe it was. Okay, and then after 5 years, which is going to be 60 months. So I delete that and I put 60 in. Okay. 2443.22. So 2443.22. Come back over here, type in 2443.22. And each of these will be talking about how much money is in your account at the end of that amount of time. Notice it grows and grows and grows. And at this rate, it takes you not quite 5 years to double your money. Most banks don't give you that much interest. This is a very generous bank. You can actually do a little bit of research on your own and plug in for these. Same equation here. Based on the different banks' interest rates, they'll usually advertise that on their websites. I'm not going to have you do that for me today, but we may look into doing a project on that later. Okay? Once again, write your starting value from the question and open your parentheses. Decide if that percent is going to help you grow or decay, if it's going to grow or shrink your values. Convert that to a decimal. From there, if it's growing, add that decimal to 1. If it's shrinking, subtract that decimal from 1. Close those parentheses, add an exponent of x, graph the equation, and generate a table, because tables usually help out a lot more. And then answer the questions. Let's go ahead and flip the page over and go to page number 2 and talk about this equation, or this question. The value of a car decreases at a rate of 5% each year. Now, if Mr. Ring purchased a car for $45,000 tomorrow, how much would that car be worth a year later, 5 years later, or 10 years later? Oh, and how many years would it take for the car to be worth half of its original value? Okay. So let's go ahead and answer each of those questions real quick. First and foremost, we want to start by writing in here about our initial value. Initial value is going to be how much the car is worth originally, 45,000. So I take that 45,000 and I start it by writing it. I open the parentheses just like step 1 says to. Again, I look in here and I say, okay, am I going to be growing or shrinking? Is it going to be increasing or decreasing? And by it, I mean the value of the car. It decreases, it actually says so right here, at 5% a year. So I need to convert that to a decimal. So I take that 5% and I kick that decimal 2 places to the left, and it is 0.05. From there, since it is decreasing, I go 1 minus 0.05, which turns into 0.95. I close the parentheses, raise it to an x, and I have my equation. That's what's going to get plugged into my function calculator on my graph. So I go back over here to my functions, and I go, okay, I need to generate a brand new table for this based on the values I've already got. A $45,000 car times 0.95 raised to the x. I got to close those parentheses there to finish my equation, and that generates my graph here. Okay. Wow, that line goes really far down really fast. But again, that's very, very, very misleading because look, it's at 1,000 down here on the x. That's 1,000 years later where we're at. If I continue looking here, I got 200 years later when I'm finally getting close to 0. If I'm at 100 years, like I'm still worth some money. Let's go ahead and again take a look at our table and talk about what's going on here. The first part was after 1 year. I know there's not a blank for it, but we're still going to write something in for that, okay? So let's go ahead and change this 6 to a 1 for 1 year. My $45,000 car is worth $42,750. So 42750. I'm going to go ahead and write that in because, again, I didn't give you a blank for it. I'm sorry. Okay. 1 year is 42,000? Yep, 42,750. 42750. That's how much it's worth after 1 year. Now, what about 5 years? Again, I use the table and I make this change from 12 back to 5. You'll be using your arrow functions on it. It's going to give you a chance to scroll up and down that table, and you'll notice after 5 years that we are at $34,820. Okay. Yes, we could put the decimals on here for that, but in this case, let's talk about just the 34,820. So 34820. Get out of here. You're in the way. Text 34,820. Okay. And that is going to be the amount after 5 years. What about 10 years? Okay. I'm willing to take some bets. You think it's going to be worth half the amount that we started with, the 45,000? You think it's going to be worth less than half of what it's originally started with? Remember, half of 45,000 is 22,500. So if you think it's going to be worth more than that, maybe less. All right, let's check it for 10 years. And, well, 26,943. So 26,943. Notice this is not half of the value yet. 26,943. That's how much money is worth there. Again, if we want it to be half of the original value, half of 45,000 is 22,500. That's the money we're looking for. So that means it's going to be worth more than 10. So at this point, I'm going to have to guess and check. You guys can scroll up and down the table to see at what point you go below 22.5. In this case, I'm going to guess at 15 years. Not 5, 15. Excuse me, missed a button there. Okay, 15 years, it's worth 20,000. So I'm worth less than half. So it's not 15. So maybe 13, which is kind of in the middle. Instead of 13, 23, 1. Okay, we're getting close. We're getting close. What about 14 months? 21, 945. Okay, I'm getting really close to my 22, 5 between years 13 and 14. So I'm just going to go ahead and say it's going to be about 14 years. I have seen questions like this asked on a STAR test, and in most cases, the years are going to be like way off from this. You're not going to get a choice of either 13 or 14, or it'll say something like 13 and a half. And honestly, if we look at this, we could try 13 and a half and see how close we got. And yeah, it's about 13 and a half years, but about 14 years is something I would be happy to take right here. In this case, again, it is a good thing for you to have those calculators. Once you get that equation typed in, again, menu 3-1 to get your f of x, type in the equation like we have here, the 45,000, open parentheses, 0.95, close parentheses, raise it to the x. You're going to do menu 7 for table, 1 to show table, and it's going to let you use those arrows to go up and down between your different x values until you're able to answer these questions. It's a lot easier for you guys than it is for me to use Desmos. I'm going to let you go ahead and get started on your worksheet.